In this video, we present an overview of SAII software. SAII software is the user interface for the Model 1030MR compatible small animal monitoring and gating system. The hardware for the Model 1030 is covered in another video. But briefly, it consists of data acquisition modules located near the scanner and near the patient, and a control gating module located near a PC that's running SAII software. The PC is positioned out of the scanner room, usually near the operator console, and can have a remote display. Clicking on the SAII icon on the desktop opens the software. This window gives options for going to a setup menu to configure the monitor, or run SnapView, and we'll say more on this later, or to just go to the monitor display with the current setup. We don't have an animal connected to the system, so there's no physiological measurements. We'll present animal data later, but for now, we just want to introduce the structure of the main display. This monitor is configured to do electrocardiogram, pulse oximetry, respiration, and temperature. Several other monitor functions are optionally available, including invasive blood pressure and capnography. Along the bottom of the display are a series of buttons, a message window, stopwatch, and the date and time. When the snapshot key in the lower left is pressed, 36 seconds of all previously measured data is written to a snapshot data file. This snapshot feature gives us an excellent way of making training videos without the need to sedate an animal. We will use SnapView to play back snapshot data files previously collected with an animal in AMR scanner. Snapshot and SnapView are covered in detail in a separate video. Here we're just going to use SnapView as a training tool. Using the exit button, we close SAII and then reopen it again from the desktop icon. But this time we open SnapView. We select a snapshot data file and run the viewer. The display presentation is very much like that of SAII with just a few exceptions. One difference is the keys in the lower left. In SAII they were snapshot and trend. Here they are setup, rerun, export, and print. We only have 36 seconds of data. But by right-clicking on the rerun key, playback will automatically restart after 36 seconds. Let's focus on the cardiac cycle. We can speed up the sweep and freeze the display. Note that the electrocardiogram is composed of the QRS complex, the neural stimulus that initiates the heartbeat, followed by a T region, when the heart is collapsing and blood is flowing, and finally the P region, at the end of the cardiac cycle. The system automatically detects the R wave and displays a red dot, or in this case a red bar, in the cardiac sweep display. The number of red dots per minute determines the heart rate. The period is the time interval of the cardiac cycle. Right-clicking on the ECG waveform opens the RDetect setup window where the user can adjust the ECG gate detection parameters in real time. The RDetect blanking period or blanking time is a very useful feature. Once an R wave has been detected, the software inhibits our wave gate generation for the blanking time. This feature can be used to eliminate false triggers from gradient vibrations. In that case, the blanking time should be set to exceed the M or scanner acquisition time by about 10 milliseconds. The RDetect algorithm is based on 2 or 3 points and their positive and or negative slew rates or slopes, amplitude/time. The waveform shown exhibits our wave gate generation for factory defaults. Positive peak with a positive slope of 200 microvolts in 6.7 milliseconds and a negative slope of 98 microvolts in 4.4 milliseconds. The gate is generated at the end of the negative slope. In this example, the R wave is about 400 microvolts in amplitude. The positive slope requirement is easily exceeded, and the gate is generated as soon as the negative slope requirement is satisfied. Note that the peak in the plethysmograph waveform is delayed relative to the R wave. The delay occurs because it takes time for blood to travel from the heart to the pulse oximeter sensor site, which in this case was the paw. I'll restart the waveform and return the sweep to 6 seconds. Clicking the speaker icon turns on an audible indication of the heartbeat. There's also a speaker icon for respiration. Note, in addition to the red bar indicating R wave detection, there's also a white dot. The presence of the white dot indicates that a trigger pulse has been output from the system's control gating module. When gating is implemented, the output gate is sent to the scanner's control electronics to allow image data acquisition to be acquired synchronous with the cardiac and or respiratory cycle. This allows cardiac CNA blood flow images and images free of cardiac and respiratory motion to be acquired. A detailed discussion of gating is covered in the 1030 operation manual and a separate video. The peak of the plethysmogram waveform is also automatically detected by the system. The indication that the peak was detected can be displayed in the cardiac sweep display. Right or left click in the region to the right of the red icon to select Plet Gate. Note that a red bar is displayed above the peak of the plethysmogram waveform. Both heart rate and oxygen saturation are calculated and displayed. On the left side of the waveform, a signal scale is displayed. The number gives a measure of the strength of the pulse oximetry signal. Weak signals will be 5 or less. Strong signals 10 or more. The respiration waveform is displayed along with respiration rate and period. Note that a red bar is displayed above the expiration portion of the waveform. The number of red bars per minute determines the respiration rate. Since the respiration rate is lower than the cardiac rate, the respiratory sweep is normally slower than the cardiac sweep. Temperature measurements are displayed in the 5-minute trend with the most recent measurement entered on the right side of the display. The system normally has one channel of thermistor temperature, but several channels of fiber optic temperature are available as an option. Fiber optic temperature sensors are rugged, reliable, and both CT and MR compatible. However, they are more expensive than thermistor sensors. 2 buttons appear at the bottom of the display. These buttons select which measurement is displayed in the trend and in the digital display on the right. Toggle between degrees C and degrees F by clicking on the unit indication. Reviewing the buttons at the bottom of the display, we already know that the first few are different in SnapView than in PC-SAM. But the next buttons are all the same, starting with the gating button. The SysInfo button opens a window with software and firmware revisions and module status, which are covered in the 1030 hardware video. The color button allows color changes to be made for the display background, waveforms, and digits. The heater button allows control of the optional fluid heater system covered in the single pump fluid heater video. The alarms button allows high and low alarm limits to be set for heart rate, oxygen saturation, respiration rate, and temperature. The Quick Set button automatically sets the high and low alarm limits 5% or 2 degrees Fahrenheit above and below the current measured values. After making entries, click Apply. There's also a button to silence alarms for 2 minutes. Finally, there's a freeze key which freezes the display and an exit key to exit the program. Additional information is available in SAII Instruments operation manuals and on www.i4sa.com. Thanks for watching.